So, welcome to this tutorial. This is what we'll be modeling today. It's a trackball mouse. We will not be using the exact dimensions, it's just general guidelines. The main focus of this tutorial is just to look at how you can create these kind of surfaces inside of Rhino. To start, we will check the units of the file, making sure it's in millimeters. First thing to do is simply to make a straight line, 135 units, and move it to the center of our grid. Then we can start creating the profile curve in the top view. And by turning on the points, you can edit it very precisely. Then we use mirror to mirror the curve, and match curve to match both ends to each other. Make sure it's set to average. Do the same for the back. You can edit it a little bit more. And of course, you need to mirror it again to make sure it's 100% symmetrical. Then in the right view, we can create the profile curve of the side view. We will also rebuild this curve to make sure it has more than 4 points. Also increase the degree to 3. Now you can see you have a nice curve with a few points, which you can easily edit. If you want, you can create a surface already just by using these 3 curves and loft. As you will see, if you turn up the ISO curve density, all the ISO curves come together in one single point. That's in fact not what you want when modeling NURB, so you should stay away from these kind of surfaces. Also, you don't have a lot of control over the front view shape, so we'll be using a different method to create these kind of surfaces. So first we will extend this curve by going to curve, extend curve by arc to point. If you press enter, you can use the radius of curvature of the existing curve. So if you press enter, you can see it limits the extension a bit. Do the same for the other side. And we will immediately rebuild this curve, so we end up with less points. Edit it a bit more. Now we will be using a cutting plane to split this curve, so the end point and the start point are in the exact same height. And next we will be drawing the front view curve. I'll use the quad points of our guideline to make sure it's a symmetrical shape. Next I'll be using a cutting plane again to split this curve, because we want to edit it a bit more, and we only want to edit on one side and mirror it later. So we rebuild the curve with 5 points, and we use scale 1D. Make sure the project option next to the object snaps is turned on. Turn on the points. We can extend it a little bit. We need to mirror it again and use the match curve to make sure it's tangent. So if you look at the shape we have right now and compare it to the drawing, it's maybe a bit too high. So we will be selecting these curves and use scale 1D to make it a bit lower. Just a little fine-tuning. And again, mirror and match the curve to make sure it's 100% symmetrical and that the transition is tangent. And then join it. So next I will be copying this curve by using the object snaps to the beginning and the end point. And again use scale 1D to make them a bit flatter. We will also be using scale 1D to make them a little bit narrower. And I will also be rotating the curves a bit more so that it's more or less perpendicular to the side view curve. Next I will be drawing the final curves with the interpolate curve option. And mirror this curve also. So now we have a nice network of curves, and we can go to surface curve network to create a very nice surface out of these curves. Of course, this shape is really too big, so we will be cutting it away using a profile curve in side view. So again, I used the freeform curve to draw this one. And now we will split this surface with this curve. Make sure you select the correct viewport. So you can see the shape we have now. It's a bit too small, beginning and the end, and a bit too wide. To solve this, we need to edit our cutting curve. So first I will move the entire curve a bit down and use the edit points to fine tune it. You can see where the red curve ends. We need to split at the intersection below. Again, I will select our network curves, create the surface and split it again with our profile curve. As you can see, the beginning and the end points are a bit better now, but still too wide. So to solve this, we need to in fact edit our original network surface curves. So again, I use scale 1D just to make it a bit narrower. And again, close it up with an interpolate curve. And make sure the object snaps are turned on. I lock the top view curve just to make things a little bit easier to select. And check it in the top view. So now we're getting very close to our original guideline curve. But still some very small tweaks, especially on the back side. So now this is close enough for the tutorial. As you can see, we have a very nice shape now. And I will be organizing the file just a little bit. Move all the curves to the red layer. and turn it off. It's always a good idea to save your file every once in a while. Next, I will be duplicating the edge of our surface and use the set points option in the Z direction to flatten it. Then with offset curve and the true points option, I can offset this curve perfectly. Delete the original one. But if you turn on the points, you can see there are way too many points. So we'll be using the rebuild curve option again with 18 points. And again, create a cutting plane through the center. Split the curve with this cutting plane. You can see this is pretty nice. Only the beginning and the end have too many points. So we will be using mirror and match curve again to make sure it's a perfect symmetrical curve with tangent transitions. So this will be our base curve to make the bottom surfaces. First, I will be using a cutting plane again and use the option curve from objects intersection to create an intersection curve between the cutting plane and our base surface. This will make it a lot easier to create our section curves because we can easily snap to the endpoints. We don't need the guide curve anymore. So now we go to surface sweep to rail, select the two rails, the two cross sections, and make sure you choose the closed sweep option. That looks good, so press enter and join it to the top surface. Then use the solid option cap planar holes to close the bottom. And next we will be creating the trackball itself and the two buttons. So the easiest thing is a trackball because it's just a simple sphere. So draw a sphere and move it into place. So now we can use the Boolean difference to cut away this little ball. Make sure you set the option not to delete the input. Now you have a nice edge, but you can fill it. The button shape is a bit more difficult. It's more like an ellipse shape. This is a little bit too big, so we use scale 2D to make it a bit smaller. And try to move it into place. It's a bit more angled, so we'll be using the rotate tool. Also in the side view. And we try to get it as close as possible to the top surface. Extrude this curve into a solid with the both sides option turned on. Select our body and the button and copy it 100 units further away. Then use the Boolean difference option to cut away the button shape. And on the other side, we'll be using the Boolean intersection to create our button. Now we can simply fillet these sharp edges. I forgot to Boolean this out on the other side, so I extrude it again, mirror again, and use Boolean difference to make the hole on the other side of the trackball. And fillet this edge as well. Because we copied the button 100 units, it's easy to get it back into place and simply mirror it. Final step is simply to fillet the last sharp edges on our model. Maybe one is a bit too small, so try 2.5. And use something bigger on the bottom side, something like 4. Unhide everything. There is still a curve in our view, so we will move it to the layer 1 and rename it curves. So now we have a neat and organized file.